What's up, and welcome to Redox Lesson 10. So we're going to start off with just a quick introduction that's going to review some of the stuff that we've learned in other lessons that you need to know before going forward in Lesson 10. So looking at the notes here, you can see that there are some blanks we got to fill in here. So the first thing you got to remember is that, let me switch over to my pen here, that everything we've done so far has been looking at voltaic cells. Okay? And voltaic cells have three things that you need to remember. They will always have a positive voltage. They will always be a spontaneous reaction, which just means as soon as you put the chemicals together, they react. And that they are converting a stored chemical form of energy into electrical. Okay, and that's what we've done with everything so far. Basically, all the diagrams, all the problems, all the questions you've had so far have been voltaic cells. Electrolytic cells, we talked about this earlier, but we haven't done any yet, is exactly the opposite. So you have a negative voltage when you do your calculations. These are non-spontaneous reactions. So they don't happen alone. If we put these chemicals together but just in a beaker, nothing happens at all. We have to do something to force these reactions to take place. And that's where the negative voltage comes in. We have to force in, like shove in electrons in order to make this happen. And then the third one is we're using that electrical energy that I was just talking about, and we're going to end up storing it in the form of chemical energy in the cell that we're looking at. Okay. So those are the things that are different between the voltaic cells and the electrolytic cells. Make sure you're pretty comfortable with those. At the bottom here, though, these are the 5 constants. These are the 5 things that always apply to every single electrochemical cell. Now remember, electrochemical is the broad term, not electrolytic. Don't get those confused. These 5 constants apply to everything. So the first one is that if it lost electrons, that was oxidized, and that's happening at the anode, right? If it gained electrons, it was being reduced, and it's happening at the cathode. So my personal way again, Leo Anderson is a Gurk. I know it's stupid, but that's why I remember it. Again, when you're going through cells, that's my first step always. Identify your OA, identify your RA, figure out where the oxidation is, the reduction is, find the anode and the cathode, because that tells you everything. After that, remember that the electrons always flow from the anode to the cathode through that external circuit. Not through the solution, but through that external circuit. And then we have that the anions move towards the anode, and cations move towards the cathode. So those things are always going to apply whether it's a voltaic cell or an electrolytic cell. So make sure you keep these ideas in mind as we move through these other examples, that those things always apply no matter what. All right, let's dive in.